Bismillahirrahmanirrahim. Dear student, think for a while that how the scientists work on these elements to arrange it into groups and period in the modern periodic table. Definitely a good number of scientists work on it. They they try to their best to develop their own sort of periodic table, and finally they come to know about the exact the modern periodic table. If we are talking about this one, definitely we will start over the history of periodic table with the Russian scientist, and he was Dmitry Mendeleev. Dmitry Mendeleev noticed that when the elements were arranged in order of increasing atomic mass, certain similarities in their chemical properties appeared at regular interval. Now, how he did it and how he present his periodic table, for that we have to focus on this one.
Today's periodic table, on the right, had a very simple but inspired beginning. Let's explore how it was developed. In the 1860s, Dmitry Mendeleev organized the elements into the table that you see here. He did this by writing each element and its known atomic mass and other properties on small cards and then arranging them into columns so that the atomic mass gets bigger as you move downward. He also arranged elements with similar properties into rows, which he called periods. Notice that his table had some blanks. Did these missing elements exist? Mendeleev thought so, and he was right. He predicted the properties of the undiscovered elements that later filled these spaces. Today's periodic table looks different, but it is based on Mendeleev's work and the table he developed. One main difference is that elements with similar properties are grouped in the same column instead of the same row. Can you organize elements into a table like Mendeleev did? Click the...
So, dear student, Mendeleev created a table in which elements with similar properties were grouped together. A periodic table of the element he presented for the first time. Okay, now dear student, look, Mendeleev, when he was placing the element in his periodic table according to the increasing atomic mass, so he noticed he placed iodine before tellurium. If you look into his periodic table, it is over here. So look into this case, elements are arranged according to their increasing atomic mass. But when we are talking about tellurium, iodine over here, look, it starts from 112, 116, 112, 122, and over here. Now the problem exists over here. Tellurium atomic mass is 128, while that of iodine is 127. So he placed the elements according to their increasing atomic mass, but here, this one, the pattern is not following over here now because this one is less and this one is more, tellurium. Why he placed these elements in this order? Why he didn't place iodine on the top of it followed by tellurium? The answer is that although this contradicted the pattern of listing the elements in order of increasing atomic mass, it allowed Mendeleev to place tellurium in a group of elements with which it shares similar properties. If I'm talking about tellurium, sulfur and oxygen, they have the same chemical properties. And when we are talking about iodine, bromine, chlorine, fluorine, these have the same chemical properties. So iodine could also then be placed in the group it as resembles chemically, which includes fluorine, chlorine, and bromine, and so on. Now, dear student, Mendeleev also left some of these spaces over here. Look, this one, 68, 70, and over here it's 45. He left these spaces. Why? He was thinking that these elements will exist. So what had happened in 1871, the Russian chemist boldly predicted the existence and properties of the elements that would fill these three spaces. So in 1886, all the three elements had been discovered. Today, these elements are known as scandium, gallium, and germanium. And their properties are strikingly similar to those predicted by Mendeleev. Now, dear student, how the Mendeleev, we are talking about Mendeleev right now, how he developed or he arranged the elements. Definitely, he focused some of the properties. Which properties? Melting point, boiling point, mass, atomic mass, or something else. So we have to look on this activity over here.
Your challenge is to organize elements by their properties. What patterns do you think you'll find? Click a property to start. Then drag elements to the table so that they are in a logical order based on that property. Values for each property should be arranged continuously across rows. Click OK to check your answers.
Okay, dear student, now I'm going to select here the property atomic mass. So these three were placed here, and the rest of the elements I have to place here focusing the atomic mass, the increasing atomic mass. So if I look over here, the boron has an atomic mass of 10.81. After that, I will place carbon over here, followed by nitrogen, that is 14.01, and then aluminium, that is 26.98. Silicon is already placed here, that is 28.08. And after this, better if I will place phosphorus, that is 30.97. And then after gallium, I will put here germanium, that is 72.63. And this one is more, that is 74.92 arsenic. So I placed all these elements according to their increasing atomic mass. So I followed one pattern here. So let's see whether it's correct or wrong.
Mendeleev also put the elements in order of increasing atomic mass. He noticed periodic patterns in other properties when he did this, even though a few elements didn't fit the pattern exactly.
Now we can select the next properties, that is boiling point. So we will focus the boiling point and arrange the elements over here. We can also take the next property, that is melting point. We will arrange the element according to their increasing melting point, and we will get a pattern over here. This is how Mendeleev took the properties and made a pattern. Now look, dear student, this is the last part. Focus over here now. Now in this case, I select boiling point and I arrange the elements according to their increasing boiling point. So
now the table is organized so the boiling point increases from left to right across each row. Mendeleev also placed elements with similar properties in the same row.
Let me select now melting point and arrange the elements according to their increasing melting point. I place the elements over here according to their increasing melting point.
The elements are organized so that the melting point increases from left to right across each row. Information such as this helped Mendeleev further understand the elements and their properties. As you just saw, the elements are placed in a different order based on each property. Mendeleev went through a similar exercise when he developed his early periodic table. He noticed that some properties repeated when the elements were arranged by increasing atomic mass. The idea of repeating or periodic properties led to the modern arrangement of the periodic table. Mendeleev had several holes in his periodic table. Based on the properties of known elements, he was able to predict the properties of elements yet to be discovered. Can you? The boiling points and melting points of several elements are given. Use what you know about periodic patterns to predict the properties of these missing elements.
Dear student, we have these options and we have to take these elements and put it in the designated blank over here. So over here, if I'm talking about the E1, its melting point is given here. For the rest of the three, the boiling point is given here. So definitely, let me check the boiling point of the first two. So the melting point of the first two, it is 863. and this one is 839 degrees Celsius, and this one is 1668 degrees Celsius. So if I will put it over here, it means that the melting point exists between 839 degrees Celsius to 1668 degrees Celsius. It is within the range of these two. So next one, I'm focusing the boiling point. So the boiling point over here is 691 degrees Celsius, and over here it is 3336 degrees Celsius. So I have three options over here. So definitely better if I will take this one, because it is more than 691 degrees Celsius and less than 3336 degrees Celsius. In the last one, the boiling point over here is 4409 degrees Celsius, and this one will be in the increasing series now. So let me check it now.
That's right. Click Learn. The modern periodic table still shows some of the same relationships that Mendeleev found. Here, boiling point and melting point increase from left to right, and similar values are generally found in the same columns.
Now, dear student, this is the summary of the Mendeleev's periodic table and the modern periodic table. In Mendeleev's periodic table, when we are going from top to down, we call it period. And when we are moving from left part to the right in this one, we call it groups. This is completely opposite of that of the modern periodic table.
Let's review what you've learned about how elements can be arranged into periodic tables. Dmitri Mendeleev arranged the known elements of his time by their atomic masses. He noticed repeating patterns in the properties of the elements, like melting point and boiling point. Amazingly, he was able to use his table to predict the existence and properties of elements yet to be discovered. Mendeleev's periodic arrangement of elements paved the way for the modern periodic table. As scientists learned more about atomic structure and how it affects the properties of elements, they made changes and adjustments. Today, elements in the periodic table are arranged by atomic number instead of atomic mass. Elements are further grouped into 18 columns based on their common properties.
Now, dear student, you must understand that this periodic table was based on increasing atomic mass. In some place, you notice that they were not following the rule that was assigned that all the elements should be placed according to the increasing atomic mass, like over here. It's very clearly mentioned here. But in 1911, the English scientist Henry Moseley, who was working with Ernest Rutherford, examined the spectra of 38 different metals, and then he presented a modern periodic table. So Moseley's discovery was consistent with Mendeleev's ordering of the periodic table by properties rather than strictly by atomic mass. For example, according to the Moseley, tellurium with an atomic number of 52 belongs before iodine, which has an atomic number of 53. So what he said that today's Mendeleev's principle of chemical periodicity is correctly stated in what is known as the periodic law. So the physical and chemical properties of the elements are periodic function of their atomic number. So the modern periodic table, this one, is based on increasing atomic number. You can see over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And if you reach the last element, this one is 118 over here now. Dear student, the modern periodic table was presented by Henry Moseley in 1911. Thank you very much.